This movie is for Unit 9 on transformations, learning target 4, composition of isometries. Rigid motion can be expressed as a composition of reflections. So that means several reflections put together. The term isometry means the same distance. An isometry is a transformation that preserves distance or length. So we have translations, reflections, and rotations are all types of isometries. They're also forms of what we call rigid motion. You can express all isometries as compositions of reflections, which is interesting. The composition of two or more isometries is an isometry. Here are 4 kinds of isometries, and I won't test you over these 4. Just see that they make sense to you. Translation, we have the rotation, reflection, and what's called a glide reflection. A movement, and then a reflection. So reflection across parallel lines. This is what you would do. You've got your 2 parallel lines. We have our pre-image. How do I know which one's the pre-image? That does not have primes, so this is the pre-image. And we're taking that pre-image, reflecting over this first line, we'll call line L. It's a cursive L. And reflecting over this point, we get B goes same distance, perpendicular to B prime. C, same distance, perpendicular to C prime. A, same distance, perpendicular path, we get A prime. Then, when we reflect over line M, A travels perpendicular, same distance, that's perpendicular, to get A prime. B travels perpendicular to get B prime, same distance here. C maps to C double prime, and that travels at a perpendicular with the same distance on each part here. So you do one reflection and then do another reflection. Now, here is one way of writing a composition of isometries. This means to first reflect over line L, which you'll see here. Then second, take what you reflected and reflect over line M. So if we took these and we call it X, Y, Z, let's go ahead and do that. Try this on your paper. Let's first reflect over line L. So Z is going to be equidistant, traveling at a perpendicular path. Same distance, opposite side to get Z prime. And then the Y is going to do the same thing. Sure, use a ruler. That is a great idea. You can see that I am not, and it is not looking the best, is it? Okay, there's that guy. Yeah, could be a little better, but not too bad. Now we're reflecting over M, so it's going to be a ways away. There's Z double prime. Y double prime. X double prime. And then we're back to the orientation that we originally had. There you go. That's how you do that. Look, it looks like a translation, doesn't it? From this pre-image to this image, it looks like a translation. So this double reflection ended up being a translation. So make sure you have that on your paper. Then let's go on to the next one. Reflections across intersecting lines. So look at this. This is interesting. Here is our pre-image. I know that because it doesn't have any primes. And the first reflection's over line L. So we reflect over L and we get this image. That seems to make sense. Then we reflect over this line with the image. And we get this double prime. And so A composition of reflections across two intersecting lines looks like a rotation. So this composition of isometries results in a rotation, which is pretty cool. Let's try over here. Let's give it a go ourselves. The first thing we're going to do is reflect over the line L. And we're taking this letter J, reflecting over L. Ooh, dear. You give this a try. This one's hard. Give it a try, though. And then, secondly, we're going to reflect over line M, which it's got to map, and you can try to map it or just sort of see the reflection. I think I'm a little too close to the line. But then you can see from the original that it ends up looking like a rotation. It's kind of hard to make. But try that on your own. And then let's go down here. Any composition of isometries can be represented by either a reflection, translation, rotation, or a glide reflection. A glide reflection is a composition of a translation, which is a glide, and a reflection across the line. So you can see the glide and then reflect. So let's try this. This is a new notation here, but it means a translation of this. X plus 0, y minus 5. This is kind of a vector notation. Then a reflection over the line x equals 0. You will not need to know this notation. I will always write it out like this. So translation is the first thing we want to do. And we want to translate x plus 0. That means we do not move left or right. Y minus 5 means we go down 5. So each of these points need to go down 5. To get t prime, x prime, and e prime. Write that down, and let's put our coordinates over here. Make sure you're adding that to your paper. T prime is at -5, -3. E prime is at -1, -2. And x prime is at -2, -4. Then reflect over the line y equals 0. Or I'm sorry, x equals 0. X equals 0 is going to be Hoivux, VUX. X equals a number. It must be a vertical line at 0. It actually is the y-axis. The y-axis is the line x equals 0. So we're going to reflect over this line and we get e double prime. X goes 2 away, x double prime. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. T double prime. And we end up with our double primes where T double prime is at 5, -3. E double prime is at 1, -2. And x double prime is at 2, -4. Okay, make sure you have that on your paper. It's just doing two transformations, taking the image from the first transformation and applying it to the second one. Let's go to this one. Pause this movie, try this on your own, and then press play when you are finished. Okay, this means we want to go to the right one. This means we don't go up or down, so we just go to the right one. There's T prime, E prime, X prime. And then what we want to do is reflect over the line y equals -2. Hoivux, hoi is y equals a number, which means we have a horizontal line. So horizontal at -2 is here. So we graph that line. 1, 2, 3, 1, 2, 3. Get x prime. 1, 2, 3, 4. 1, 2, 3, 4. T double prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And E double prime. So we get this triangle down here where our prime was at -4, 2 for T prime. E prime 0, 3. X prime was at -1, 1. T double prime is at -4, -6. E double prime is at 0, -7, and X double prime is at -1, -5. So see how you did with the double transformations. This is just applying two transformations to the same preimage. And that's all for this movie. Thank you for watching.